Our lesson for today is all about basic geometric constructions for regular polygon. In this lesson, we are going to study about construction of regular polygons. Let us first define what is a regular polygon. A regular polygon is a polygon that is both equiangular and equilateral. So when we say equiangular, all its angles are the same measure, and when we say equilateral, all its sides are the same length. A basic example of a regular polygon is an equilateral triangle. It is a triangle with 3 congruent sides and 3 congruent angles. Squares are also regular polygons because all their angles, which is 90 degrees, and all their sides are the same length. Regular polygons with 5 or more sides do not have special names. Instead, the word regular is used to describe them. For example, a regular hexagon. A regular hexagon is a hexagon which is a 6-sided polygon whose angles and sides are congruent. All regular polygons have rotation symmetry. This means that a rotation of less than 360 degrees will carry the regular polygon onto itself. In fact, a regular or n-sided polygon has rotation symmetry for any multiple of 360 degrees n. Constructions are a step-by-step procedure used to create precise geometric figures. To create a construction by hand, there are a few tools that you can use. The first one is a compass. It is a device that allows you to create a circle. It can also help you copy distances. Next, we have the straight edge or ruler. Anything that produces a straight line, you can also use a ruler as a straight edge if you only use it to draw straight lines and not to measure. And last, we have the paper. When a geometric figure is on a piece of paper, the paper itself can be folded to construct new lines. You can construct some regular polygons by hand if you remember the definitions and properties of these regular polygons. With the additional help of geometry application software or a protractor, you can construct any regular polygon. Now, let us find out how to construct an equilateral triangle. So step 1, make an arc of points that are the length of xy away from point x. For our step 2, make another arc of points that are the length of xy away from point z. And for our step 3, let's connect points x, y, and z, and now you have an equilateral triangle, which is a regular polygon. Now, there's another way on how we can make an equilateral triangle. Now, let us look at a given example. XY is one side that will become equilateral triangle XYZ. You need to put point Z in the correct place in order to make the equilateral triangle. Where should point Z be placed with respect to points X and Y? Now, let's proceed. For our step 1, let's use the straight edge to draw line segment XY. Next, for our step 2, let's use a compass to measure the length of XY. And for our step 3, let the distance between X and Y be an A and mark point Z with the same distance of XY away from point X and Y. And for our step 4, using a straight edge, draw a segment by connecting 2 points to form an equilateral triangle XYZ. As you have observed, when point points X, Y, and Z were connected, a triangle is formed. It is equilateral. Now, let us learn how to construct a square by paper folding. Constructing a square by paper folding. Step 1. Fold the circle so that the two halves overlap to create a line or crease which will be the diameter of the circle. For our step 2, fold the circle in half again to create the line that bisects the diameter. To do this, fold the circle so that the two endpoints of the diameter meet. The second crease will also be a diameter. Next, for our step 3, there are two diameters formed that are perpendicular to each other. Using a straight edge, connect the 4 points of intersection on the circle to construct the square. As you have observed, a square is formed by connecting points B, C, D, and E, and it is equiangular and equilateral. Now, let us look at the given example on the next slide. Points C, A, R, and E are on a circle, centered at point O. Show that CARE is a square. CO is congruent to AO, which is congruent to RO, and congruent to EO, because they are all radii of the same circle. Since angle COE is a right angle, angle EOR, angle ROA, and angle COA must also be right angles. All four right triangles are isosceles because they have two congruent sides. This means that their base angles are congruent because the vertex angle of triangle is 90 degrees. The base angles of each triangle must be 45 degrees. The four angles that make up the quadrilateral are each made of two of these 45 degrees angles and are each therefore 90 degrees. Since the quadrilateral has four congruent sides and four 90 degrees angles, then it is a square. This time, let us construct a pentagon inscribed in a circle, but first, let us define inscribed in a circle. Inscribed in a circle means all vertices of the polygon are on the same circle. Now, let's proceed to constructing a pentagon inscribed in a circle. For our step 1, draw a circumference and its perpendicular diameters to obtain points A and B. Find the segment bisector of segment BO, obtaining point X. For our next step, open the compass from X to point A and draw an arc that will intersect in Y. The distance A to Y is one side of the pentagon. Next step, open the compass from A to Y, take that distance to the perimeter, and you obtain point F. Next step, place the compass at F and repeat the distance or repeat that distance 4 more times to find the vertices of the pentagon F, E, D, C, and A. And for our last step, using a straight edge, connect the points along with A to obtain the pentagon. As you have observed, a pentagon is formed after connecting the points A, C, D, E, and F, and it is equiangular and equilateral. Lastly, let us know how to construct a hexagon. Constructing a hexagon inscribed in a circle. The regular hexagon below has been divided into 6 congruent triangles. What type of triangles are formed? The triangles formed in the regular hexagon is called equilateral triangles. A full circular rotation is 360 degrees, so each angle of the center of the hexagon must be 60 degrees. This is also why regular hexagons demonstrate rotation symmetry at multiples of 60 degrees. The 6 triangles are congruent, and the 6 segments connecting the center of the hexagon to the vertices must be congruent. This means that the 6 triangles are all isosceles. The base angles of each of the isosceles triangle must be 60 degrees. The measure of each angle of all the triangles is 60 degrees, so all triangles are equilateral. Since the 6 points are evenly spaced, each of the segments connecting the 6 points must be the same length. Therefore, the polygon must be regular. It has 6 sides, so it is a regular hexagon. So how to construct a regular hexagon inscribed in a circle? So for our first step, start by constructing a circle and a point on the circle. Second step, you know that the radius of the circle is the same as the length of each side of the hexagon. Therefore, your goal is to place 6 points around the circle that are the same distance apart from one another as the radius of the circle. Keep your compass open to the same width as the radius of the circle and make one new mark on the circle. For our step 3, continue to make new marks around the circle that are the same distance apart from one another. Step 4, the circle should look like this after marking all the 6 points around the circle. And for our last step, using a straight edge, connect the intersection points to form the regular hexagon. By connecting the 6 points inscribed in a circle having same distance from one another, we were able to form an equilateral hexagon. And that is our lesson for today, which is the basic geometric constructions for regular polygon. Thank you for watching.